There are 4 collection types that are used to store collections of data, which is the storing of multiple items, lists, tuples, sets and dictionaries. In this video we will have a look at tuples. A tuple is immutable, which means it cannot be changed, and a tuple is written with round brackets. We can add any data type within a tuple, such as integers, floats, strings, boolean values, etc. And we can see in the example tuple, my underscore tuple, it has random data inside it. But a tuple is typically used to group related data. For example, it might be a record of a list of people or person's ID or information on them for, let's say, insurance purposes. For example, their name, age, marital status, job, address, criminal record, driving history and so on. So this is just an example of the type of information you could see inside a tuple. And like I said, a tuple is ordered. Items have a defined order and that order will not change. But unlike a set, a tuple is unchangeable, so we cannot change, add or remove items after the tuple has been created. And like I said, a tuple allows duplicate values. This is because they are indexed. And you can use tuple items with any data type. In terms of use case for tuples, a tuple is faster than a list, and the main reason is it protects you from accidental modification, since a tuple cannot be modified. Python has 2 predefined built-in methods that can be used on tuples, and these are count and index. There's not many, there's only 2, and this is because you cannot change anything on a tuple. You can only gather information about a tuple. So a count will count the items or elements or values, sometimes they're called items, sometimes they're called elements, sometimes they're called values, and return the number that the item exists within the tuple. So for example, the item blue could exist 3 times within the tuple. So this will tell you that it exists 3 times. We will have a look at it shortly. And then there's index, and index returns the index of the first occurrence of an item in a tuple. So it tells you where it is inside a tuple, its index position. And we are back on PyCharm. I've copied my tuple, so I'm going to paste it in, and let's print the tuple to make sure it prints. My underscore tuple, and we can see on the right hand side the tuple prints to the screen. And if I type my underscore tuple dot, we can see the methods that the tuple supports. So there's only count and index as methods. We can see if we go further down, we don't have the other methods like we have with the list, which are append, insert, clear, etc., as we cannot update a tuple or change it in any way. Typically what we would do if we wanted to modify a tuple, we would convert it to a list and then modify it and then reconvert it back to a tuple, or we would create a brand new tuple instead. And these other ones that look like methods, they all have a double underscore before and after. These are known as magic methods, or also known as dunder methods. They perform things like logical operations, mathematical operations, object comparisons and sequence operations, and they are beyond the basics of learning Python. So we are not going to cover them here. And the first method we will take a look at is count. In the last video on lists, I created a variable x equals and then printed x to show how the count method works. In this video with tuples, we will directly print using the method without having to declare it first. So let's look for the item London and let's print it directly to the screen and run the file. So we can see it says there's 2 occurrences here of London. We can see one here and one over here. If we type something else like 5.5, we can see it over here. We should only see 1 occurrence. And we only see 1 occurrence of 5.5. Now if we wanted to see the index position of 5.5, let's type in index and double click it here. So the index position is 0 and then it's 1. So 1 is the index position. Let's run the file and it shows us 1. And if we wanted to see the index position of London, there's 2 occurrences of London. Let's type in London. As it shows you the index position of the first occurrence of London, it should show 0, 1 and 2. So the index position should be 2. Let's run the file and we can see it's 2. And we could do many other things with tuples. We can use loops to look for items in tuples as well. Let's say, for example, if So we are saying if London is included in my tuple, in is the keyword for include, then print yes. Let's run the file. And we can go on, so we can do an else statement to say otherwise, print no.